Hello everyone, my name is Teja Veera and uh, I am a student at Lewis University. Welcome to my phase 1 through 5, and here I have the project report first, in which I will explain the few things before going into the implementation side. So what is my project? My project is an IT asset management database built for a mid-sized IT consulting firm operating under alias TechStream Solutions. Currently, this company relies on scattered spreadsheets to track company issue hardware. My database solves a critical business problem. For example, lost equipment during employee turnover and the inability to track expiring hardware warranties. The primary users of this system will be the IT administrator and the HR manager. So now I would like to show the entity relationship diagram, in which we can see we have multiple tables, total of 5, and now here we have the tables for manufacturers, device types, employees, devices, and assignments. So employees stores the personal details like names, emails, and departments, and similarly the devices table store contains the physical hardware inventory tracking specification like serial numbers, models, and status. Similarly, the assignments table, it is a junction table basically, which actually employees and devices was having the many-to-many relationship. So that's why like it is the junction table we created here. And then we have the manufacturer and device type entities, and these are the lookup tables storing the reusable descriptive data. The core of the system is the relationship between employees and devices. Since one employee can have multiple devices and one device can be assigned to multiple employees over its life cycle, we have a many-to-many relationship here. So I resolve this by creating the assignments bridge table, creating two one-to-many relationships. The database reaches third normal form. All attributes have atomic values, means it is in the first normalization form, and then there is no non-key attributes are fully dependent on their primary keys, means it does not have any partial key dependency, so it means it is having the second NF or second normalization form. And third, there is no transitive dependency, so we can say like it is in the third normalization form. Now moving on to words, I would say I will go for the database, and I deleted the database previously so that I can show in the live demo how we are doing all this. So here is my script file. I will quickly copy and paste the queries and show how it is in everything is going on. So here we have I am for the first query I am creating the database. Execute. I will connect it from here. It is connected. No issues found. Completed. And once I will refresh the database, here we have the database and it is created. For now, we can see there are no tables in it since we did not created any. So moving on to the next step, we will create the tables. So we have 5 tables in which, like, specifically I wrote them in a sequence so that the tables which are having the foreign keys, those will come like those are written in the letter. Like here you can see in the fourth number I Fourth and fifth number, we have the table which contains the foreign keys so that there are no reference integrity issues if we place them before. Because if I will be executing all of them concurrently, then it will be helpful because it will execute from this point to line by line, top to bottom. So once the upper tables are like tables manufacturer device types and employees are created already, then we have like a foreign key which is referencing to the device manufacturer. So the thing is like here we have the manufacturer table already created and we do not get any error on the reference integrity on the foreign key. Let's execute this one, and here it is also executed successfully. And now let me refresh the table database, and here we can see we have the all the tables here. For now, we can see there is no data in here. All the uh, tables are empty for now since we did not entered any queries, insertion queries through which like we will enter the data. So now I will run the queries for insertion. So here we have the queries for all the five tables. So let's execute them. Oh, yes, we can see uh, uh, the query is generated, no issues found, query successfully executed. So to verify if the data is inserted there or not, let me write the select queries, select static queries so that we can check either our insertion queries get successful or not. So here we can see each and every table contains the data. We have five tables, 1, 2, 3, 4, 5, and here we gave the data in it, inserted the data in the previous query, and they are here. So now we will move towards the queries like join queries, order by queries. So such queries I will write one by one, and uh, I will explain the queries what these queries are doing. So first of all, let me write this query. Yeah. So this is a multi-table query. Actually, this is a multi-table join across three tables. Since this was our first one of the requirements in the phase 4, that we have to write the query that will join 2 plus tables. So for that, to fulfill that requirement, I wrote this query that joins the three tables, which tables devices, manufacturers, and device types. It provides a master asset report to see the full details of what the company owns, linking the device to its category and manufacturer. And here I will execute it, and here we can see the data. What, as I said earlier, what it is showing the full details of what company owns, linking the device to its category and manufacturers. Here we have serial number, we have a model name, manufacturer name, description, status. So it is covering all those three things. So next uh, we will write the query It is grouped by query to cover the group by query requirement. What it does, it is actually device counts per manufacturer query. This is an actually aggregate query using group by. It summarizes the inventory by counting how many devices belong to each manufacturer. This helps the business understand vendor reliance. So let's execute this one. Here we can see manufacturer name, and for each manufacturer how many, you can say the here we have the assets, means how many devices they have. So here, since we entered the raw data, so here it is showing 111 for each of one. So next query we have, it is about filtering and sorting. Let's copy this query and pasting here. Yeah. So here are the results of this query. So what is this query telling us? It is telling us the high value regional assets, about the high value regional assets. Here I am using filtering and sorting as I told you, as I mentioned earlier, and I am filtering the devices using a where clause for a status of assigned and purchase date after the 1st of January of 2025. I am then ordering the results by purchase date and in the descending order, so the newest asset appear first. So in the same way, the newest asset will appear the first, then second and third. In this way it is like ordered. So moving on to the next query is about it gives us the custody report. So let me first paste the query. Yes. So now this is another three table join between employees assignment and devices. This is the heart of the database utility, as it identifies exactly which employee has which device. Let's execute in, yeah, which employee has which device and what the current condition of the hardware is. So that's why, like I'm saying, it is the heart of the database utility. Like it is a custody report. Okay, so now moving on to the next query. Let me copy from here and then paste here. Yes, let's execute it first. Okay. So what is this telling us? This query is about the departmental hardware needs. Here we are using an aggregate query combined with filtering. It counts the device held but filters specifically for the engineering and IT operations departments using an in clause. So here it gave the results like IT department have two devices, IT operations have one device. So moving on, the last query we have, the query number 6. It contains a sub query and we also use the filtering in it by using the where clause. And what this query is, let's execute this one. What this query is telling us. So it is actually telling us about the unreturned assets. And here we have the query using which uses the filtering to find unreturned assets. It searches for assignments where the return date is null, meaning the employee still has it. And the data issued was after October 2025. I sorted this alphabetically by the employee last time. So here the first name, email, date issued, but these guys did not return the assets. So that was all. Now I will move to the I will conclude it. And so the thing is, by implementing this relational database, TechStream solutions can seamlessly track their hardware life cycles, enforce accountability, and completely move away from manual spreadsheet tracking. And that was all. So just a second, let me explain more things from here. Like in the report, I have mentioned the details about the entity and attribute description. Like employee store the personal details, devices contains hardware specifications, so this and that. The basic thing is like the relationship and the cardinality justification. So, as I told earlier during the explanation of the entity relationship diagram, there is a many-to-many relationship between two entities. So, whenever there is a many-to-many relationship, we cannot have the you can say the ERD in the third normalization form, and it is the better approach to reduce the redundancy, to minimize the redundancy, that we keep the our database in the most normalization form, that is usually third or fourth normalization form. But to achieve the to achieve the fourth normalization form, we have to achieve the third normalization form. So for that purpose, like we have to always whenever there is a many to many relationship between two entities, we also have we always have to create a junction table, or we also say that bridge entity, or we can say junction entity, junction table. So then what happens, both the many to many things are connected with the junction table with one to many relationship, and in this way we resolve this thing. So moving on next, let me check if there is anything that needs to be described. So yeah, this is all about the details of the tables, which like I already mentioned earlier. So yeah, now for foreign keys and primary keys, every table has its primary key. It cannot happen that if there is any table and it does not belong have it is not having the primary key. So primary key is the one thing that is mandatory to maintain the structure of the database in the normalization form. So because the primary key is the thing that identifies each and every attribute in that table. So, but the thing is, the foreign key we talk about, then a table can have it and table cannot have it. It depends on the scenario. For example, here we have devices can entity have the foreign key, manufacturer ID, and type ID. Means the device entity is connected with manufacturers and device types. And if two entities are connected with one-to-many relationship, then the table which is on the many side, one-to-many side, it will have the uh, because one manufacturer can have the multiple devices, so that's why like manufacturer ID is there. Similarly, there are foreign keys for the assignments table as well, and it has employees and devices. So moving on next, we have the data types like integer, varchar, since employee ID is stored as integer 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it is integer. First name is varchar, as it is a string values. So similarly, yeah. Everything is going on in the same way. Your relationship description, I already told those things, and here are the screenshots for the reports. So that was all, and yeah, thank you so much. That was all. Thank you.